Today, I'll be speaking about categorizing Python videos with a graph database. Let's start off by taking a look at what happens when you do a web search for Python videos. Of the top 10 results, typically 5 are paid courses. Excuse me, there's so much great content. I don't want to pay for a course. I just want some good free videos. Okay, let's take a look at the first one. That's data analysis from 2000 and data analysis with Python from 2015. So you're telling me that Jupyter Notebooks hasn't changed since 2015? Or Learn Python for data science, same thing. Actually, what I really like is this fourth one. Let's scroll down here. Python tutorial, no, where is it? Learn Python in 5 minutes, right here. Learn Python in 5 minutes. Man, what did I spend 20 years learning Python for? God, I must be dumb. Okay, and the worst part is if you scroll down, you basically get these infinite lists of videos. Okay, so let's take a look at pyvideo.org. They've been collecting information about Python videos since 2008. They have thousands of videos there. And actually, by 2016, they were covering 192 annual conferences plus innumerable meetups. Um, but sadly, the number's gone down, and by 2018, so far this year, they've only covered 7 annual Python conferences. So for example, if you look for, I did a search on pandas, there are 100 videos, 99 of them are from 2013 to 2017, and only one of them is from 2018. So there's a lot of old content in there, so the whole site's becoming less relevant. They need to clear out all the junk. So now let's take a look at pythonlinks.info and see what happens. So pythonlinks.info currently has 589 videos. I had about 50 a week, one conference a week. They're organized as a tree of categories and they're ranked by upvotes versus total votes. So here we have the root of the tree. So you can see the 10 best overall videos, and they all have a perfect score of 100, and that's because these didn't get any downvotes, and that's because they're the best videos. And let's see what happens when you scroll down. So remember that a basic principle in human factors is shouldn't have more than 7 or 8 items in every category. So when it's a tree of categories, and so when we scroll down, let's scroll down, we see a machine learning category, and then we can swipe right or left. We can see the 8 other categories: data science category, parallelism, this includes multi-threading, multi-processing, distributed systems, Python in the organization and the community, some more human factors talks, Python skills development, and here we have Python software. Let's just go back up again, and let's just jump into this tree. So the leading talk, 101 votes currently, is on pandas, towards pandas 1.0. Actually, Marcus, charming Spaniard guy who did this talk. And let's just click in, and you can see this takes us way down into the tree. On the upper left-hand corner, we can see where we are, the best Python videos, data science software, pandas, and towards pandas 1.0. And again, we can swipe left and right, and we can see the other talks on pandas. There's actually even a whole category of talks on pandas. We're at 8.8. Oh, we need to swipe the other way. This was somewhere in the middle of the tree. We can see all the different talks on pandas. We can go up, and here we can see the best talks on pandas overall. There are 4 items of this category. We can also take a look at the list view. And so that was the best view, which shows everything in the tree. The list view just shows what's in this particular node. And so as you go up, there's one subcategory in this particular node and a whole bunch of videos. And as you go up, you typically find that so here you have just data science software. You just have 4 categories. Go up a level, data science, you have 1, 2, 3, 4, 5, 6, 7 categories. Best Python videos, you have all categories. Okay, so let's take a look at how we built this beast. Switch to this view. So I built this using a graph database. There's quite a large market of graph databases. Here are 5 of the largest graph database vendors. Between them, they received $250 million in venture capital. So there's a lot of money flowing here. but mostly they're in Java. And Java is just not as flexible as Python. So what am I supposed to do? Do some of my stuff in Python and go under the hood and try to do Java? No, thank you. It's much better to use a graph database that's been written in Python. Much more flexible. So I'm using the ZODB. It's in use in Plone, it's in use in Pyramid, Flask ZODB, and Cromlech. So Plone's a content management system. Pyramid, I'm sure many of you heard of. Flask ZODB, not as well known. It has some 35 stars on GitHub. And Cromlech, well, there was something called Zope and Grok, and they've kind of gone by the wayside. They had just too much junk in there, too much complexity. Suhel Chelfu has spent the last 10 years cleaning up these libraries. He's just done a brilliant job. And so he's released something called Cromlech. I'm so impressed by him. And of course, the biggest user of the ZODB is Plone. So there are a lot of users of Plone all around the world. Just the government of Brazil has 100 different Plone sites. That's the president's office, the parliament, different government organizations. So, and Jim Fulton has spent the last 20 years polishing up ZODB. So they only got 2.5 million dollars in funding, but that was 20 years ago. And so by now the software is really polished, very nice, just rock solid, just really wonderful stuff, well supported. Okay, so how do we use this thing called the ZODB? Well, it's really easy to use. You just, instead of subclassing off object, you subclass off persistent. So here we have a tree leaf. We have an initialize method that basically sets the title. We have a render method that displays the title. And we just have to import persistent and subclass off persistent. So you basically get persistent object, persistent set, and the important one is a persistent dictionary. So what that is, it's a B tree on the file system, but it looks to the user like a dictionary. So we call those containers. And you subclass off of those are the nodes of the tree. So you subclass off of those and your objects become persistent, your graph of objects becomes persistent, your whole application becomes persistent. Really, really easy. Okay, so how do you add a leaf object? So first we're going to create a leaf, tree leaf, and you can just say root. You start off with a root object and you say root.leaf equals leaf. Okay, so that's for one object, but in reality you get lots of objects. So use these containers. And we're going to create, on the right hand side, we're going to create two different leaves, and then we're going to set root of leaf 1 equal to leaf 1 and root of leaf 2 equal to leaf 2. So that's basically how you add stuff. And of course there's some boilerplate that goes around this stuff. There are multiple different storages. The simplest one is file storage. And so the first thing we have to do is create a DB. So we'd say ZODB.db and we give it a file name, data.fs. We get a connection to the file. We ask the connection for the root object, and then we do some stuff. We create some objects. We do some transactions. We do some changes to those objects. Transaction.commit, everything works. And this outer stuff, this boilerplate stuff, usually all of the frameworks will handle it. So I actually had to look it up because I never see that stuff. And of course, it's just Python. So, I mean, it's really just Python, really easy. No SQL selects. So let's see. First, we're going to update the leaf. So we get the root object, and we say, give me leaf 1, and set the title to be yellow leaf. Transaction.commit. Okay, done. We may have a stupid query. For key item in root.items, print key and item. Also very simple. You may want to delete an object on the right-hand side. Delete root of leaf 1, transaction.commit. So it's just Python, so it's really easy to use the ZODB. You don't have to learn some other tools. So it's really magical. What it does, it gives us the illusion that we have these persistent objects. So we don't have to worry about our database schema. We don't have to worry about an object relational mapping. We don't have to worry about integrity constraints. We don't worry about garbage collection. All that stuff just done for you. Just simplifies my life so much. And it really is a graph database. Now, throughout this talk, I'm going to be talking about trees, but really they're graphs. Usually what happens is people begin using it as a tree, and then as their application gets more complex, it becomes a graph. So let's just start off again. We've got two tree leaf objects. We're going to add them to the root. Root of leaf 1 equals leaf 1. Root of leaf 2 equals root of leaf 2. And now what we're going to do is going to cross-link them. So we got a very simple leaf.sibling is leaf 2, and leaf 2.sibling is leaf 1, transaction.commit. And so now we have a very simple triangle. There's a root, it's got two leaves under it, and they each connect to each other. Okay, so you can access the leaves by either of two paths. What happens when we delete one of those paths. If we delete root of leaf 1, well, the objects are still accessible because you can go to leaf 2 and sibling and get to leaf 1. Okay, so it's only when we delete the second one, it's only when we delete both of them that those two objects are no longer accessible, and so they get garbage collected. So this is what we call persistence by reachability. If you can reach the object, it's persistent. If you can't, then it gets garbage collected. Okay, so the simplest way to use the ZODB is by with Flask ZODB. This had 35 stars on GitHub. So Flask has this concept of routes. And so basically, in Flask, you define a function that does something, and then based on the URL, you call that function. So Flask gives you a very simple model of a tree of ZODB objects, and you've got some functions that you call based on what your URL is. Very, very simple, not a very high level of abstraction. What most of the people are using ZODB, they use traversal. So this would be Plone, Pyramid, Cromlech. That's what I'm doing. We use traversal. So we have some URL, and it's just so natural to map that URL into a tree of objects. So the root object is slash. If you go down to the right, you've got slash software. Down to the right further, slash software slash libraries. All the way in the bottom right corner, slash software slash libraries slash database libraries. So this is called traversal. Most of the ZODB platforms support this. It just makes web development so easy. And then the question is, once you get to that object, what do you do? So again, Pyramid, Plone, Cromlech, we all do what are called views on objects. So the last slug in a URL, the last little text between the slashes, it's a slug, is determines which view. And so you've got multiple views on any one node. And in reality, there are different views on different nodes of the tree. So you may have one branch of the tree that's account objects, and one of the views is add an account object. Well, that add account object only works on that collection of accounts. And so you've got these complex rules for which views you can apply to which nodes of the tree, and basically all of the, or most of the ZODB tools support this model of user interfaces. Plone and Cromlech give you additional features. So here's an interface for a video class. This is based on zope.interface. And the idea of zope.interface is you do a declarative definition of the interfaces, both the instance variables and the methods, to the extent that you wish. And so here we see that there are three instance variables defined for a video. The first one is the title. This is what the humans sees it. The second one is a brief description. And then the third one is a source, which is typically the HTML from the conference website that describes the particular video. And then so basically you have to create the object, but then with this zope.interface, you get the cred for free. Actually pops up the interface for you as well. So here's so to add a video, I just have to define this. Basically, we're just defining the key things. A lot of it's kind of a boilerplate. We have to say the slug that goes in the URL is add video. We have to tell it that you add the videos to conferences. This is very important. You can only add it to a conference. You don't add it to a general category. Add video, you define the class. It's a subclass of add category. There's an interface, which is what we just saw a moment ago, a subtitle, which is user sees, and a factory, which basically is the conference video class. So when you do that, once you do that, you basically get a nice interface that does the whole thing for you free, including this whole HTML WYSIWYG editor. Okay, back to the talk. And so we've got add categories, add videos, add conferences. There's a whole bunch of other stuff you can add, but that's less relevant to this talk. Okay, back to the slide, next one. And so this is these decorators are very similar to what Pyramid does. Very explicit, you have to define each item. Another ZODB library called Grok, what it did is it could inherit, and so you only have to define the things that have changed there. Everything else could inherit from the parent. So I like that, but that's not the way the world goes. The next question is, how do I categorize these videos? So I import 50 to 150 videos at a time from a conference. Okay, everybody knows how to scrape the web and do that. There's a pretty easy API on YouTube. And then I have, so let's take a look at one of these videos. This is actually already sorted, but let's say I wanted to move it someplace else. So I have this very nice interface here, and we're just going to move it to the same place just for fun. I can either, here is fancy tree. I can either do a search and it'll tell me what the where I am. It's under fancy tree, data science, pandas, and then I can move it there. Or actually, what happens is usually because I know the tree very well because I've been sorting. Usually, what I'll do is I'll just say, okay, data science software, pandas, and I can see what's there and I move it. And after I move it, I just moved it back to exactly where it was. I guess Nords and Outs at the end of the list. But after I move it, it pops me in here because usually one of the principles in human factors is that you don't want more than about 7, maybe a few more items in a category. And so what it does, it takes me to the category and I can see right here how many items are in the category. 8. Okay, so that's good enough. I don't need to change it. But then if I need to, I can look at the different talks and then I can split them into subcategories. I'm a big believer that the world of software is so complex that machine learning and there's not a good data set. Machine learning is not really there at the point to be able to categorize this kind of content because the readers are very smart. They can tell if something's in the wrong place or not. And maybe there's not enough of a data set pre-categorized. Actually, I was talking to the Spacey people and they said, man, once you get all this done, you'll have the most amazing categorization data sets, and then you can start doing some machine learning stuff on all the other junky videos that are out there. But why would I want to if they're not such good videos? Anyhow, that explains how I do the sorting, the categorization of these Python videos. Okay, let's talk about ZODB asset properties. So ZODB is a proper database. It's got atomicity and consistency and isolation, durability, all the stuff you expect. But it's more than just your typical database. It's actually a version database. So it keeps historical versions until you pack them. So that has big impact, and it has particularly big impact on the CRUD demo. So in traditional relational database, you have create, read, update, and delete. In the ZOP world, you also have rename, because you can rename where somebody is, what the URL is, the path to get to it. Cut and paste an object or a branch of the tree. Copy and paste an object or a branch of the tree. History, restore, and undo. So let's take a look at that. So here we have our ZMI, the browser. Here we're at the root, and we can click into, it's a tree. It's just a very nice way of viewing a tree. You can click into different topics, and you can see with the breadcrumbs where you are. You can click back up to the management view. When you get in, you can edit an object. We can click back up to the root. It's a big tree. So we can rename things, right? So what are some of the CRUD we can rename? I don't want to actually rename it. Products, I can change the name of it, or if I want to, let's just reload that. You can take some of these branches, you can cut, copy, delete them. If you cut or copy them, then you can paste them somewhere else. So you can it's really easy to take a branch of the tree and move the whole branch to someplace else. And so that's really important for categorizing content because the tree is continuously changing. Let's show you the most interesting piece, which is the history piece. So let's take a look at the demo for history. Before I came here, I asked James, a marketing person, to help me with the website content. So this is what he did. Oh, that's a nice image. I like that. What did he say? The ZODB is just awesome. It's amazing. It's fantastic. I love it. It's great. You should be doing it, using it. Why are you not using it? That's terrible. That's abusive. Let's get rid of that. What I want to do instead is let's take a look at the historic version. So remember, ZODB is a version database. So here are the different versions of this. The first version I did, the next version I did, the first version he did. You can see his versions. We can actually take a look at the source. Yeah, that's the one I want. So let's go ahead and restore it. And now when we go ahead and edit it, there we go. Much better, much nicer. But I did like his image, so we'll put his image back there and we'll get rid of his text. What we'll use instead is we'll use my text. There you go. And now we have a much better version of, we can save and view it. So it's really nice when you're doing content editing to have these historic versions where every version is available, rather than if I use my text editor, Emacs, then only the most recent version, or Git when I do a commit, but not every version. So this is really good for content editing. Okay, back to the presentation. Um, the next topic is canonical URLs. So we can have a tree of URLs, but then if you traverse it, every time you move objects around, the URL changes. So that's not good at all. So you really need canonical URLs where there's like every object has its unique name, and then from the root you access it. So this is great because then every object just has its unique name, and even as you readjust the tree, as new content is added, things are moved around, no problems. But the problem is it makes it a graph, and so that way the browser, the ZMI browser, it thinks it's a tree, but actually it's a graph, and it's worse than just this. It's not just that you can access it by traverse or from the root, but actually each of these videos is part of a conference, so that's a bidirectional link, ZODB's proper graph database, and maybe they have an author's name or multiple authors' names, so those are also bidirectional links. I don't have names in yet, but they'll come. And so what do you do? So let's go take a look at this. We can go back up. Let's go back up to the root, take a view. We can go see some arbitrary video. Let's go to the manage view. Manage. Okay, now take this, so here's that best talk towards. I can delete this. Now, usually you think of this as just a tree view, and so you delete it, you just access it, remove it from its parent. But here, it's actually a graph, right? My domain model is a graph, and my browser is a tree, so you've got some disconnect there. So what we do is we have these adapters that hook them up together. And the adapter knows if you're deleting something that's a video, then you have to delete, first of all, it knows that it's a category, it's a subclass of category, so from the root you've got these canonical names, it has to delete that. It's a video, you have to delete it from the conference as well, and eventually name, you're going to have to delete the person as well. So if you go ahead and delete this, right, it does all of that for you. Oh shit. That was actually my best talk I just deleted. That was stupid. Oh damn, why did I do that? Anyhow, I guess I'm okay. I'm okay because remember, it's a version database. So we're going to go into transactions, and here's the transaction where we can see deleted towards pandas, and we updated Python London meetups. And we can just undo it. So that's undone. And now when we go back, and we reload the page, we can see that it's right back there. So it's really nice to have a version database. Here's the talk. Let's see. Okay, so it's a graph database. We have a graph of objects on the server. We download it as a JSON file, so that's not a tree. We can link across it. You can imagine this link is a hyperlink. Actually, it's a single-page web app, so it actually knows the canonical name, and so it loads instantly. Okay. There are some other options. Let's see, we're at EuroPython 2018. Let's go ahead and search. And here, when you search for EuroPython, it shows you all of the different talks organized by category. And we can, maybe what we want to do is search on DevOps. Well, it used to be there weren't any DevOps talks. Now there's one, so you'd actually find the category. But there is a DevOps category, and you can see all the different talks in the DevOps category. What other options do we have? Contact. You can contact me, Christopher Lozinski, pythonlinks.info. Just click on that contact piece. You can follow pythonlinks.info. Thank you very much. Have a wonderful day.